Types of functions, part 2. The graph of the function f of r maps to r of x maps to x squared minus 2 is shown. So we see we have a U-shaped graph. The points minus 2, 2 and 2, 2 can be found on the graph. It crosses the y-axis at minus 2, and the name of the function is f of x equals x squared minus 2. So it's the general function x squared. It's just been moved down 2 steps. So we can see that it's symmetrical about the y-axis. So the y-axis acts like a mirror line. And then we have 5 questions to answer in relation to this graph. So part 1, what is the range of f? The lowest y value of the graphed function is y is equal to minus 2. And I've highlighted that there in yellow. Therefore, the range of f is y greater or equal to minus 2 or square bracket minus 2 comma infinity curved bracket. So the range is from minus 2 and including minus 2 up as far as infinity, positive infinity. So when there's a square bracket, it means that that value is included. So if this had been a curved bracket, it would indicate that minus 2 was not included. It was everything above minus 2. But because it's a square bracket, it means minus 2 is included. So everything that's greater or equal to minus 2, that is the range of f. Part 2 asks us to explain why f, the function, is not injective. So f is not injective as any horizontal line in a given range will intersect the curve at more than one point. So I've drawn in 3 horizontal lines just to show 3 examples of where this curve is intersected at 2 places for each line. So we've 2 points of intersection for the first line, 2 points of intersection for the second line, 2 points of intersection for the third line, and so on. So therefore it's not injective, because injective means a one-to-one function. And if a function is injective, it should intersect the curve. Any horizontal line in a horizontal line test should intersect the curve once and only once. Or minus 2 is mapped onto 2, and also 2 is mapped onto 2. So again, it is not a one-to-one function because minus 2 is mapped to 2 and 2 is mapped to 2 as well. Hence, there is not a unique output for each input. Part 3, explain why f is not surjective. So the function f is not surjective as the range of f, the function f, is y is greater or equal to minus 2, and the codomain of f, the function, is capital R, which represents the real number set. So all numbers on the number line. So positive, negative, whole numbers, fractions, decimals, all the numbers on the number line. So I've highlighted there in yellow the range, which is y values greater or equal to minus 2. But the codomain is the entire y-axis if you think about it in terms of a number line. So the codomain is different to the range, therefore it's not surjective. So if you were to think of this in terms of a mapping diagram, there would be elements inside the set that do not have arrows going towards it. So for example, minus 3, we can clearly see that minus 3 would not be highlighted in yellow, as minus 2 is highlighted in yellow and all the values above it on the y-axis. So for example, in a mapping diagram, minus 3 would be one of the elements that does not have an arrow going towards it. So therefore it's not surjective, because there can never be an element that does not have an arrow going towards it if you want to call a function surjective. So f is not surjective as the range of f is y is greater or equal to minus 2, and the codomain of f is r, the real number set. Since the codomain and range are not equal, f is not surjective. So in order for a function to be surjective, the codomain and the range must be equal. Part 4, suggest a domain for f, the function, to make the function injective. So if the domain is restricted to x values greater or equal to 0, then we get this diagram. So this is our x-axis and this is our y-axis, very roughly drawn. And we can see -2 is the lowest point of our graph and goes up presumably to infinity. So we're basically taking the right-hand side, so the positive part of the x-axis, we're basically taking the right-hand side of our graph. So if you imagine that we've cut a line down the middle, the y-axis, we've cut a line down the middle and we've only taken the right-hand side of the graph. So if we restrict the domain to x values greater or equal to 0, so the positive part of the x-axis, so the right-hand side, this is the graph that we get. Since a horizontal line will intersect this graph at one point only, this function is injective. So we can see the green line drawn in here. So this is a horizontal line, horizontal and parallel to the x-axis. And we know that if we were to move that green line anywhere from -2 upwards, it would intersect the graph once and only once. Whereas if we had a horizontal line cutting through the graph above, it would intersect the curve in 2 places, no matter where we would draw the horizontal line, except if we drew it exactly at the minimum point. But still, the fact that it can intersect the graph in 2 places is what we're interested in. So the above graph is not injective, but on the bottom, taking just the right-hand side of the graph, taking just x values greater or equal to 0, what we have formed is injective, because now this horizontal line cuts this graph in one place and one place only. So no matter where we would move that green line up or down, it would intersect only once. Whereas with the graph above, the horizontal line test would intersect the graph in 2 places, wherever you move it to, except for the minimum point of the graph. Part 5, suggest a codomain for f, the function, to make the function surjective. So if the codomain of f is restricted to y values greater or equal to -2, then the codomain and the range are the same. So I've highlighted there in yellow the y values greater or equal to -2 and assume that it just keeps going upwards to infinity. So now the codomain and the range are the same if we restrict the codomain. Therefore, the function would be surjective. So if we restrict the codomain to y values greater or equal to -2 and continue going upwards to infinity, so basically what I've highlighted, but continuing going upwards, then the codomain and the range would be the same, and therefore the function would be surjective.